This is the README first document. So I'll post this link once I'm done with doing this video. Some information that we're going to dive into right away is peer-reviewed research. And I go through what peer-reviewed research is. You're going to need to know this for the purposes of your semester project, because your semester project is going to highlight some peer-reviewed papers. And peer-reviewed papers are simply papers that when we publish, we actually have other people who do similar research review that work prior to it being published. And so I talk about that a bit more in that video. And there's some value to looking at peer-reviewed research. The other video that you'll watch is the critical review of literature. And I go through how to read a research paper. You don't necessarily read a research paper from the first line to the last line in the article. You can actually jump around, and you can jump around when you understand all the different components that are included in that paper. So I go through that a little bit more, and I talk about how to be critical of the material that's being presented, but not just critical. All right, I know that sounds odd, but trying to develop a critical mindset is important when you're looking at research papers. I always say that researchers are negative people. We take a negativistic approach to answering questions, and what we actually try to do in a research project is try to disprove hypotheses or show situations that something doesn't work the way that we think it works or worked. And so we're always trying to disprove hypotheses as opposed to prove hypotheses. And so that's why I always say we take a negativistic approach, and we're very negative people because we're trying to disprove things. So I talk about that a little bit more in both these presentations. So that'll be good to go through. And then watch this presentation. This is describing the semester project, which is really an important part of the semester and what you're going to be doing. This is where you'll be picking a question that you are interested in, and you're going to try to answer that question based upon peer-reviewed work and some other aspects. And we'll continue to build this project throughout the semester. Newton's laws, I've got this presentation. This is one I got to redo. For whatever reason, it's gone, and I can't find it. So I'll redo it. But Newton's laws are really very simple to remember, and you may already know them and have them memorized. But what we'll find is applying the laws can get a little tricky. So Newton's laws are really quickly summarized as first law is a definition. It's law of inertia. It's an object first law is an observation. An object will stay at rest unless something comes along and changes that situation. Or to extend that a little bit more, an object will continue with its state of motion or state of velocity. We'll substitute that unless a force comes along and changes that velocity. All right, so it's just an observation. Once something gets moving, it's going to continue to move. If it's not moving, it's not going to move until a force comes along and changes that motion. So law one is just an observation. Law two is a definition. And sorry, I misspoke in the beginning. It's a definition of what a force is. And what a force is we can determine how fast motion will change using a particular equation. We determine how fast a force changes when we can identify all the forces acting on an object, and we understand some characteristics of the object, the mass of the object, which represents the object's inertia or the amount of resistance to change motion. But if we know all the forces acting on the object, and if we know the inertia of the object, we can understand how fast the motion will change or how fast velocity will change, which we'll learn, and some of you already know this, that's acceleration. So sum of forces acting on the object equals ma, or F equals ma, is Newton's second law. And we'll spend a lot of time dissecting this equation and using this equation to understand movement, because it's the A is the kinematics, and then motion, and F is the kinetics, or the forces that cause motion. All right, so law 2 is just a definition. Law 3 is really Newton's contribution to understanding motion and physics in general. And what law 3 is for every force acting on an object, there's an equal and opposite force created by the object. All right, super easy to remember. I'm sure you've all heard this law before, but it gets a little confusing when we're trying to understand how to use Newton's second law. So Newton's third law says for every force acting on an object, equal and opposite force created by the object, or the other way, every force created by an object, there's an equal and opposite force acting on the object. All this means is if I push on a table, you can't see, but if I push on the table pushes back on me, equal and opposite forces. Great, all right? If I push on the ground pushes back on me. If I push on this cup, the cup pushes back on me, equal and opposite forces. Not a hard concept to understand. But to use Newton's second law, all we do is identify forces acting on the object, not by the object. That's fine too, but what we'll actually find is sometimes we're interested in the force created by the object. For example, if I'm the object, the person, I want to know what forces I'm generating to create some motion. Well, to do that, what we often do is measure forces acting on me, and then use the understanding that some of the forces acting on me are equal and opposite to forces I'm creating. So this is where it can get a little complicated using these three laws together. Law of inertia, an object at rest will stay at rest, or an object continue with some velocity will continue to move with that velocity unless a force acts on the object to cause a change in motion. Law 2 is a definition of what a force is, F equals ma. Add up all the forces acting on the object, we can understand that object's motion, acceleration. And law 3 is really the true law of Newton's three laws. It states that if for every force acting on the object, there's an equal and opposite force created by the object. But when we use law 2, we only identify forces acting on the object. So we'll do some practice in that. And I've got some practice even in this week assignment that I'll show you. All right, so go through a little bit more of that detail in this presentation, or I will, because I got to redo it. And then some more information on a kinetic analysis, a couple of presentations on that. And then down here, I've got a couple of presentations that I have referred to as the immersion type presentations. These are getting us in the real world of how biomechanics comes back into play to answer questions or things that are related to in this case, endurance performance. So it won't be, neither of these will be specific to biomechanics, but you're going to start tuning your ear to hear biomechanic issues. So every week we do a Las Vegas Tri Club member spotlight where myself and another person, Bob Gambo, we do a interview or a talk with a member. And those members range from elite athletes to people who are just starting out in triathlon, and all different range of ages as well, from college students to people in their 70s doing races. And so what I want you to do is just watch one of these, and you can go to the playlist there because I have them all on the YouTube channel, and you can just pick one randomly. It doesn't matter. You may actually find someone that you know. And all I want you to do is listen to their story, because these are the folks that we want to try to connect with when we're doing our semester projects. All right. You're answering a question, and who you're answering the question for often drives what information you're going to put in the presentation. And so it's really important to know that we're trying to answer questions that people are asking. And the people who are asking are showing up in these spotlights. So just watch one. They're 30 minutes each, roughly. A couple are a little bit longer than that, but they're roughly around 30 minutes. And you'll hear their story related to triathlon. So this will hopefully help you see the type of person that you are going to be trying to help by answering a question. And then the other one I have here is the evidence-based triathlete that Ted Gerard and myself do. And we just did we've done a few of these, but one that I'm listing here is just focused on the new triathlete. And again, this is no specific information that will show up on a test, no specific information about biomechanics, but I want you to tune your ear to hearing some of the biomechanic issues that we may be talking about. Bike fit, picking out run shoes, picking out a wetsuit, things like this. These are all issues that the new triathlete needs to understand, and things that we're talking about. And again, this will help you with your semester project. These immersion videos are not test material, but they do show up in the way where I write some questions about a situation involving an Ironman athlete or an athlete training for an iron distance athlete. You've got to have an understanding of what an iron distance athlete or what an iron distance event is. So this is really to understand a little deeper outside our academics. All right, for your semester project, what you're going to do is find a web page or link or article from a general source like Runner's World, Sports Illustrated, whatever, Shape Magazine, any of these, but you're going to try to find anecdotes or lay literature related to the questions that you're considering. You're not narrowing down the question yet, maybe you have, but we're going to continue to work with 3 questions. And then as we progress through the semester, you're going to narrow it down to 1, probably by next week or even the week after. We really want to be zeroing in on a question at that point. Okay, so that's the overview of the week. I did want to also show you the assignment, because it has one other part to it that emphasizes the Newton's laws. Same information here. I continue to encourage you to create your own terminology list as you go through these videos. Just have a piece of paper out or a Word doc like this. And as you're listening to the video, just write down, type in, oh, I need to be able to define force. Oh, I needed to be able to have a definition and equation and units for acceleration and so forth. So inertia is another term I just used. Just as you listen to the videos, create a running terminology list, and then go back and make sure that you can define them. You can provide an equation where appropriate and units where appropriate. But the task I want you to try to tackle this week, it's not graded, all right, but to continue to emphasize this issue of identifying forces acting on an object, not by an object. And the confusion sometimes get where we add both forces created by and on an object, then that's where our analysis gets a little more complicated. So I just have these situations listed here. This is just a box floating in the water. What forces, push or pull, that tends to cause motion, are acting on this object? And all you're going to do is use an arrow to represent that force. And you're going to put the arrow on the object where you think the force is being applied. And we'll talk more about that as we go along. And you're going to draw the length of the arrow to represent the magnitude of the force. The longer the arrow, the bigger the magnitude. And obviously the arrow is going to point in the direction that you think the force is acting on the object. Okay, so do that for floating object. Here, this V and this arrow just represents this object is moving through the water across the screen that way. And then I've got another, this is in the water, and then this is another situation of an object sliding on the ground. And so I'll use this type of illustration to represent the ground. And then a final one here, this object is moving uphill. All right, so this represents a hill, okay? Sliding on that surface, okay? So 2 in the water, 2 on the land. What you will see is that these are going to be related to swimming, biking, and running. And we'll talk about each of those situations in more detail. All right, so do that assignment. This is not graded, but you are going to need to have practice putting arrows on objects and then also reading problems where there are forces acting on an object. Okay, that's it for the weekly update. Again, if you watch or if you pull up a video and it shows that it's private or you can't access it, email me right away, because that may be a video that was deleted for whatever reason and I need to redo. And I think I've caught them all for this week, but as you go along, certainly just keep that communication flowing to me. All right, thanks everybody. Have a good day. Have a good week.